Alright. We finished 5 the other day, if I remember right. So, let's do 6 today. And actually, we're going to work on lecture on 7 next week. And then the following week, we're not going to meet. But y'all still have assignments to do. And I've got to get that stuff updated out there, but I got to find my master schedule sheet too. I don't know where I've lost it to. Everywhere it should be, I have looked, and it's not there. But if nothing else, I've got in your syllabus on the course guide, tells me what's what week, so I can get it back from there. So, but I really don't want to do that because that means I got to go back and look at all the syllabi for all of my classes to regenerate the information. And I'm sure that sheet's somewhere, I just can't figure out where it is. It should have been laying in the front seat of my car, but it's not there. And I'm trying to figure out where I could have gotten it, where it could have gotten laid off separately to. So it should have either been there or on my desk. One of my desks is where it should have been. Either here, Catoosa, or at the house. And it's not at any one of those 3 spots that I can find.
You don't have it backed up?
You
don't have it backed up?
Yeah, it's backed up on the syllabi. So, as I said, I can get it back from there. So I do have, they do have a backup of it. Okay. I don't have a copy of the thing. So I did leave it at Catoosa one day a few weeks ago, and then I went back over there and got it, where I left it laying there when I walked out one day, but who knows what I have done right at the moment. And it is possible it is caught in a pile of mail at home, because all of the things going on, I haven't even been reading everything out of the mail, and it's sort of been piling up in several piles. And it may be caught in that somewhere, which shouldn't be, but it may have gotten caught in that. I thought I went through that looking, night before last, I guess. Well, not even then. Sometime in the last couple of days. Conference was pretty good yesterday. Except the speakers weren't always sure who they were supposed to be talking to, and that was sort of also the way they had the conference set. So did any of y'all look at the streaming? I get all blank looks, so apparently no. So that a good bit of it was actually aimed at the students. And there was a number that Middle Georgia had a number of students in there. Actually, Central Georgia had some students attending it too. So that they talked some about cybersecurity, of what was going on in the world out there, and then a couple of them talked about what kind of jobs and stuff and where they could find some jobs. Robins Air Force Base gave a 30-minute presentation about jobs at Robins Air Force Base and about the different directions you could go there. As he put it, which tribes you could belong to. Whether you were civilian or in the military on it, that there were both ways on that and different possibilities and stuff. But they actually had a table set up there. One of their organizations, but they said they were using them everywhere. And we had a state judge talk to us at the end, and he was interesting on how some things were doing, and then how they were prosecuting on some different things and how they got evidence and getting warrants, etc., and where his involvement came in on it. And also he talked for a few minutes, which was really interesting to me, may not have been necessarily to everybody else, but he talked about being an expert witness and stuff and what was involved in doing that and how that was handled. Because he answered some questions on that. Because when he got up to talk, he said he really didn't have a full, I think they gave him 45 minutes each or so, that he didn't have a full amount of that, but it was going to be partly, he really wanted discussion, he said. And he said, so he was going to open up for questions for sure, and he did. He said, here's your chance to ask a judge something. He said, usually you don't get to do that. And that he was technically literate, and he said that down there, he was in Houston County, and he said that in that area that he was the one that a lot of the other judges turned to for technology stuff, that he had come from a little bit of a tech background, and that they would, because he told us also that to some of the judges really irk them about the fact that they don't even do anything with computers, and are proud of the fact that they don't read emails, that they get their emails from their secretary printed out, look at them, write an answer back to the email, and the secretary types back in the answer. And he said, he told us a couple of times on that how much that irked them on it, that they needed to have some basic knowledge and do some stuff themselves. So and he said, and it's not necessarily a generational thing either, because he said you got obviously a number of older people that know computers well, and he said, and you got some younger ones that don't want anything to do with other than to play a game on it, and won't do anything. So he said it really fell both ways. He said it did fall more like you thought, but he said it's not necessarily purely a generational item. So, and then there was a policeman who does digital forensics, talked about that and doing that for the Houston County Sheriff, and actually is a go-to apparently for a number of sheriff's departments and police departments down in Middle Georgia, that because he's learned stuff. Although, as he put it, he said, because he said if you want to go into law enforcement on it, he said there's not many law enforcement groups that actually have cyber people on the force. And he said, and even on his, that's not his technically full-time job, that he's actually over a crew, and but does that a lot on the as side of his job, and then gets called in by a lot of others because he's gotten equipment and stuff. And when they built a building 20 years ago, that the sheriff got him some money, and he's gotten some grants since and gotten some different software and hardware programs to do with doing that stuff. But he says on limited budget, he said there's some things when somebody asked him about unlocking a phone or unlocking an iPhone or whatever, he said no, he didn't have the code to that if he runs into that, he sends it to the GBI, because he said he doesn't run into that very often, and two, the cost of getting some stuff was, for as seldom as they use it, it wasn't worth it to him, and so he routes things to the GBI then on it for some things like that. The GBI also spoke to us, and they had two of their forensics people speak and tell about doing some stuff, and told about a couple of cases. Primarily, they indicated a lot of their computer type crimes type stuff is porn cases and related to that, a lot of child porn and stuff. And then they had a guy they just hired in the last year that graduated from Middle Georgia 2 or 3 years ago, that they just hired on, and he told about what he was doing and how he got there, and he had worked I think he worked for I really keep thinking in my mind it was a school system, but I really don't think it was school system. I think it was something law enforcement, but he was doing something else. And then one of his professors told him that GBI had said they had a job opening. He told about that process and that it took him close to a year to get the job from the time he applied for it. Because he said first he applied, and then it took a month or two, a couple of months before they replied back to him, called him, and then after he got, then they checked some things, called him back and asked him if he was still interested, interviewed him, and that was an all-day interview, he said, with them doing stuff. Then that sat for a little while, and then they called him and said, are you still interested in this job? And they sent him through his background checks, and he had to do a lie detector test, etc. Did that, and then there was still another delay before he was finally hired on. That was sort of like when I got my first permanent full-time job teaching. That took about 7 months. Because when I had applied to Swainsboro Tech, and I had taught for 1 year down in Brunswick, but that was a temporary position while the instructor went back to finish his doctorate, and they hired me in there to cover for 1 year. And that was what I was hired to do, was 1 year teach on it, and then I was out of job. So it was a temporary job. And then after that ran out, then Swainsboro Tech, that December, actually Brunswick Junior College had told me about that they had a job for a computer instructor and needed a computer instructor. And so I contacted them beginning of December, and they said yes, they were looking for somebody immediately, and that they were going to start a brand new program. And I sent them my resume and everything there early December. They talked to me on the phone several times, and it was continuously, we're wanting to hire somebody 1st January, and it's time critical. And we were down to the last few weeks of December, and getting the stuff from me, transcripts and that stuff. Never did an on-site interview in that process, but the president of the school talked to me several times on the phone, and it was continuously, time is of the essence, and we got to get this done immediately. And I was wanting a job anyway, right then, because I didn't have a job. Because I was literally doing whatever at that point, including cleaning bathrooms at the racquetball court, and waiting tables for banquets over on the islands and stuff. So, and doing some other variety of things, whatever. If you called me and told me you had some work to do, I went to work for you. And that was up till right at Christmas, and then I didn't hear a word back. And then 1st of June hit, or late May, I guess it was late May, something. In any event, late May, 1st June, no, it was beginning of June, that all of a sudden one morning I get this phone call at 8 o'clock in the morning, or real early around then. And it's the secretary at Swainsboro Tech calling me and said, can you come for an interview next Tuesday morning or something? But it was, can you be here for an interview in X number of days or whatever? And I'm going, interview for what? And who? And after I got that figured out, because I hadn't heard anything from them in over 5 months or so, that it was, okay, I'll come for an interview. And so then I went, found where it was, went and had the interview, got there, and that was a different interview. They had brought in a lady from Waycross that handled their regional IT center for tech colleges then. We used to have data collection centers at several of the schools, that, because remember, everything was done by paper back then. This was 81. And they would send it to the regional center, and they'd consolidate all of this data that you still see mentioned out of here, but it's now done through MyGNTC, which links all together at the state. And so where they produce saying what percentage of graduates get jobs and what our graduation rates are and all kinds of other information on that. Well, she was there, and the president was there, and I went in for the interview, sat there, and the interview went to start. He introduced her and told me who he was, and then he may have asked me one question, and then his phone rang, and he got on the phone talking to somebody. And she and I sat there for a couple of minutes while he talked, and then she and I started talking. But we sat there for a little bit and started talking to each other. While he's talking, well, okay, we'll go ahead and talk to each other. And we talked about what I had done, different things that she talked about, what things, and where I'd been and stuff. And she talked on through, and we talked for probably 30 minutes or more. Him still on the phone. And then he gets off the phone and I think he asked me one thing or something simple, just some generic question, and said that was it for the interview. And I went, okay, and I left. And then I didn't hear anything again for another couple of weeks. And I get a phone call on a Friday morning, it was on Friday morning from him, of they were going to hire me. He was making me an offer, told me what he was going to pay me, and would I accept the job, and that he needed to know then. And I went, well, I'm going to have to think about this a bit, because at that point I was working for the Cloister at that point then, at Sea Island. And I went, well, I don't know if I really want this job or not, because they had moved me up a little bit and things, but they knew I was looking for something else from the time they hired me, and they had actually sent me on an interview or two. So leaving them wasn't going to be a big problem. But going, okay. I told him, I said, I got to think about it. He said, well, I got to know by Monday morning at 8 o'clock or something, 8 or 9 o'clock, very first thing Monday morning. He said, I got to know if you are going to accept it or not. He said, and then I got to take it to the board meeting that's meeting on Monday morning, the Board of Education, because we were under local boards, and for them to approve your hiring. Because you know how they have to, the Board of Education has to approve hiring every teacher in the school system and everything. I don't see it in the paper here on it so much, but in some other towns you'll see where they'll give the report on the board meeting every week, and it'll tell you who all they approved for hiring and who they approved to leave the school and everything. Because if you resign, they got to approve your resignation. But I really haven't, the papers here don't give you that coverage on it. You could look at some of the other local papers, you'll see that through the state. And he said, so he said he had to know then to tell them and to get it approved. And so they ended up, so then I called him on that Monday morning and said I would take it. And then he called me back later that day and said they had approved me. And what date was I going to start? But it took that long to get that job. And there really wasn't anything delays in it. When I came on here, it took us a few extra weeks on it. Well, there was a little bit of delay on this one because I applied and they were saying they needed somebody immediately, and then it took like a month, but I understand somebody got sick at that point before I heard back. After they had initially replied to me when I sent in my resume of time was of essence again, and when I read time is of essence, I went, I won't hear from this one for 6 months. I know how time of it is of essence works now. Because you get told that you're expecting, because they were acting like down there, I was going to be working for them the 1st of January. You know, in just a few weeks that they were saying. But then apparently they didn't get the budget, they changed. And actually it wasn't the president I was talking to. It was the vice president who became president at the end of that month. And I really think he was, my understanding was he was trying to get me hired on when he took over as president, because the other one was retiring, so they already knew he was going to do the job. But what in the world happened? I have no idea ever since what happened or why it took 6 months to get me hired. Here, I got told somebody had gotten sick that was involved in the process, and that delayed things. And so then when they had me come up for the interview, then there was a little bit of a delay for a couple of weeks on me getting on here, because we had a little bit of salary negotiation on it, because I wanted more money than they wanted to pay. And the amount they wanted to pay, I was not moving up here for. And that we had to reach a consensus on that one. And that part is normal. Because when y'all apply for a job and get an offer, you've got to then look at what you got as an offer and decide whether or not that's acceptable to you, of what they want you to do and what they're going to pay you for it and what your benefits are and stuff. Now, but I already knew what the benefits were because I'd already worked in the system. You know, the question was, how much cash was I going to get? And I got a little tight there for a little bit on the negotiations. But so you never do know. And so like on that where he had said it took them that long with GBI, that's not totally surprising being a government job, that they can follow out. So we had that, and a CPA that has gone into cyber security forensics and stuff, and is doing that now instead of doing just regular CPA stuff and going out and tracing out things and doing some different things from a civil side. He talked about stuff. And actually when the judge talked, he talked about having worked with that deputy on doing some stuff too, that the two of them had worked together on doing some different things. So it was an interesting day. Then we had a couple other people from some businesses and the security officer for the Board of Regents and stuff. He was the boring one, and he was the first one that spoke all day. His was not as good as a lot of the other stuff was, but a lot of the others were interesting and good. And so we got some things. All right. The chapter now is we're on the network layer, so we're going to move up a layer. And part of the chapter is just talking about the network layer, and then they actually go into talking about your router. And so that's where they really spend a good bit of the time in here. That's another one that was yesterday. We had, I don't remember who the guy was. Actually, it was the Board of Regents guy, I'm pretty sure. Made the comment that IP6 had only been around since 1998, I believe is what he said. That was when IP6 started. and that was not correct information. He was using something that happened then, as claiming that's when it started. Well, there was a quote IP6 launch day, and I think it was not 98, 2008, because 98's really when it really started. But there was 2008, I'm pretty sure it was 2008, it was around 2008, was an IP6 launch date, which there was a group behind IP6 that went to pushing hard for it and had a big day of, let's announce that IP6 is out there and everything, but it was already out there. It's just it was complete. There was began being a push that day on it to use IP6. That wasn't the start of IP6. And I'm going, no, IP version 6 has been around since 98, 99. I went out and looked and I found what he was talking about. There had been this launch event that day, and I went, oh, I remember that. And then soon thereafter, not too much, a year or two later, is when the federal government actually first did a test to make sure they were completely IP6 compliant. Well, they couldn't be that go out and verify on all their equipment, and it was IP version 6 compliant within a year or two of IP version 6 coming out. So that didn't do me a whole lot of good with that guy. That keep your information straight. So the network layer they talk to you about, you are working with packets now on this layer. You are working with IP addresses, and the IP version 6 and the IP version 4 packets are different looking packets. They have to be. Because after all, one of them's got 32-bit addresses in it, and one of them's got 128-bit addresses in it. Okay? So definitely have to change what the packet looks like. And of course he had in there that also an IP version 6 that it would become the version used in 2040. I think before 2040 you're going to see it very much predominantly used. You're still going to see IP version 4 used on that, but I don't think IP version 4 is going to die and go away anywhere. It's going to be at least, I said in here before, it's at least 5 years out, probably more like 10 years or a little longer. But everything's moving over to IP version 6 also, and you've actually got your equipment all running both ways. Okay? And a lot of ISPs are now issuing out both addresses, 6 and 4. Comcast does both. Some are not issuing 6s yet, but that's going to happen soon. Because there is some stuff out there that is IP version 6 only, and if you don't have a version 6 address, you can't get to it. So I think somewhere in 5 to 10 years, you'll see IP version 6 become the common one. But you'll still see IP version 4 floating around out there for a long time to come after that. Does that make sense, everybody? And by 2040, IP version 4 may well be gone. Okay? I don't think that's going to be a big concern about mine. Maybe for some of y'all, but it's not going to be for me. So then they talk about that you encapsulate the frame. You're encapsulating the segment inside the packet, not the frame. And routing occurs on layer 3. So we're routing, going from router to router. You're using routers on this layer. And so you are going to use the IP version 4 and 6 here. And really, they're going to talk about specifically the IP stuff when we get into Chapter 7. So that that's going to come up a lot there. It is connectionless, so be aware of that on IP. It is a best effort, so it doesn't establish there is a connection to the other device. It's best effort because it doesn't know for sure it's there. It doesn't confirm that it got there. Okay? And then media independent, the IP will work on whatever type media you got. So you're not limited on that one. So IP basically, and they give you this in here too, is sort of like mailing a letter, just normally mailing a letter. It's connectionless. You don't know that that address really exists at the other end. It's best effort by the post office. They give their best effort on getting it to there, but exactly when it arrives, how long it takes to get there, we don't know. So that when I mailed 2 birthday cards to people this morning, who knows when they'll get there. One of them is already late because I didn't get in the mail when I should have. The other one may or may not make it to the person. So it's connectionless and it's best effort. Okay? IP is the same way. So IP in the post office, as far as just general first class mailing, are the same thing. Okay? So they talk a good bit about that and tell you on different things on that, and that'll work crossed. They then talk about the IP version 4 packet and tell you some things that are in it. And if you compare it to the version 6 packet, you will see there is a difference there. It's 48 million. Where do they give us the number? They should give us the number here somewhere. All right, so there's 4 billion IP4 addresses. On the IP version 6, there's 340 unidillion. That's 30 zeros after a 1. Okay? Addresses. But y'all work in unidillions all the time, so I really don't have to tell you about what that number looks like, right? So there's a ton of addresses out there. Oh, and one of the things they did come back to several times yesterday in the conference was partly in terms of that, and that was IoT and about that. And actually there was one of them, and I don't remember, I guess she was the one that has her own forensics company, was talking about the medical devices and some problems on that, and where you can seize control of devices and stuff, and about ways to try to protect on that. And like pacemakers, they are supposed to be doing 2-factor authentication to getting into them and stuff, and such things on that. And so there was a little bit on that part too in terms of the security. And then I did disagree with them on one thing of one of them, of where somebody, and I liked the other stuff, whoever this was, I don't remember which one it was saying, but then he said about passwords, to use password managers, that was completely secure out there. And I'm going, no. And that I'm going, somebody's going to break one of those one of these days. And you can rest assured there's plenty of hackers trying to break it. And everybody else was saying everything's breakable. There is no totally secure nothing out there. And that everybody's trying to stay. That the black hat people are trying to get ahead, and the judge even made a comment on this. I think it was the judge, or else it was one of those last 3 made the comment about, it was the judge, I'm pretty sure, that he said he really didn't think that we really ever ahead of the hackers would ever really happen. And he said, and I don't think we really want to. Because he said, if we did totally get ahead of them, he said people would quit trying to figure out new ways and they'd completely break the whole thing at that point. So he said, it really needs to be both sides trying to keep up with the other side. And I went, that made sense. Because he said, if all of a sudden you figured out the perfect way to secure everything, everybody'd sit back and rest on their laurels at that point. And then boom, everything would just fall totally apart because they'd completely blow the whole thing up. So on that IP version 4.1, you do have a version on the very first of it. And remember, this sits inside the frame, so you don't need a start and end marker on this because this is not what's going straight out onto the wire, okay? Although you're normally looking at the packet part of it when it goes across the wire, then you're looking at that inner part of the frame. But you're really not looking at the outer part because the outer part really doesn't give you a lot of information. It just tells you which device did it just come from and what device is it going to next, pretty much, okay? It's the stuff inside there that anybody's wanting, okay? They're wanting stuff in the packet. They don't want the stuff that was added by the frame, okay? So there's a version there again, which was out there on the frame too, because that had an effect on where was some stuff going to be located on inside. So you really want to know that. You really want to know that as you do go to decapsulate it. What in the world are you getting out of there? How big of a thing are you going to get out of there? Then it does have a header on it, and then it's differentiated services one. You're really not going to do much with that one. That's going to really be local type thing and some things of how does it do some things on it. So that one really doesn't affect you too much. Then, so you really don't see that one really mentioned to you. The total length of the packet, that one will be important. You'll see that mentioned sometimes. The identification, that's something that was there, but it's really not ever been used. There's a fragment offset. The fragment offset just gets that's equaled on out because there was some extra space in there for if they needed to do some other things. And so somebody could use that if they wanted. Time to live is an important one. Okay? That tells how much longer is this packet going to exist on the network. It's normally measured in hops. As it goes from router to router to router, it will reduce the time to live by 1 each time. Okay, so when it's initially put on there, the initial machine that sends it out puts a time to live on there. Used to be 30, I'm not exactly sure what number it usually uses now. I think it's 60 or so, but they still say you should be pretty much, unless it's deep nested in some network, you should be able to get anywhere in the world typically. You can definitely get to the right network in 30 or less hops, in less than 30 hops. Okay? Now, getting to the specific machine it's going to may take longer because sometimes you've got some real nesting of routers within the network. So they had to increase it some, and I don't remember what it is that you usually put on there. But when it's sent out, it gets a time to live value put on there. Here's the maximum number of hops it's supposed to go through. And if it doesn't get there, that time is to die. That's important. That keeps things from floating forever out there on the internet. Some of you may have heard the always classic story on the subway, either in Boston or New York, I don't remember which one it was, of supposedly the guy that got on there and then could never get off of it, and then was just stuck on the subway for the rest of his life. Time to live would stop that way. After he rode past the same stop so many times, they would remove him from the subway. Okay? Never have quite totally got that one totally figured out. Because it seems to me like when the times I did ride those subways, but that was a long, long time ago, that you just paid to get on and then you got off wherever you wanted to get off. And then you had to pay to get back onto the subway. As opposed to some of the subway systems now, I believe Atlanta's that way, Washington I know is, that you got, when you put the card in when you get in, and you got to put the card in when you get off, and it goes and sees if you paid the right amount for between the two stops. And if you don't have enough there, you can't get through the gate to get off. Does that make sense? Atlanta's was not that way, but I'm really not sure if there is now or not. But the DC one I know is that way. And so you could get onto the subway in DC and not be able to get off because you didn't have enough money on your fare card to get out at any station. Does that make sense? Well, Time to Live stops that because it says you're going to, at some point. So Time to Live works the opposite of how it really works for us in real life. Because when you were born, the doctor didn't tell you that you have X number of years or X number of days to live. Right? That we all know we're going to live to some point, but we don't know what point that is when we're going to die. Okay? On the computer, it's said at the time something's created that's going on the network, these packets, they're only going to live for a maximum of this amount of time. Does that make sense to y'all now? And every time it goes through a router, it subtracts one off until it gets to a router and the router looks at it and goes, oops, it's got no more time to live. Either it belongs right here or it's not going any further. It's not going to reroute it back out. It's not going to put it on back together and send it back out. Does everybody follow on that? And a hop is just going from one router to the next router. And it's literally pictured like that, like I just did with my hand. That you'll normally see it drawn literally like that, and that's why it's a hop. It's like a rabbit jumping from place to place. That you're not going to normally see as you're visualizing stuff going through the system. Now when you're looking at connections, there's straight lines across there. But when you're visualizing how it's going across, they'll visualize it doing this to this to this. And notice it's a hop there like a rabbit. So y'all can remember hops then. Okay? So it's jumping to the next one, to the next one, to the next one. Now the wire is always drawn in straight, but when you're showing where it's going, actually going along through thing that you're drawing it through, you usually draw it like that, where it's bouncing along. But each time here, it subtracts one off the count before it puts it and changes that on the packet, and that's really the only thing it changes on the packet at that location. It's the frame stuff that gets changed. And then sends it to the next one, it looks at that and goes, before it goes to put it together to send it back out, it looks at that and goes, ooh, it's 0, quit. Don't even do anything with this any further, other than see if it belonged here, and then I'll work with it. But don't forward any further out. Okay? So Time to Live is an important one there. Protocol, which protocol is it using? Is it using IP version 4 or IP version 6? Is it an IP version 4 packet we're talking about? So obviously it would have IP version 4 marked there with the code that it uses for that. It has a checksum for that header. Notice we had a checksum for the whole frame also. Now we've got another checksum sitting here. So all of that stuff it does a calculation on. So it really does change two things in there: Time to Live and double checks the checksum. Then the source IP address, which is 32 bits long, because in IP version 4 it's 32 bits, 4 bytes long, and that's why when you look at numbers on IP version 4 addresses, they only go up to 255, because that's the biggest number we can store in 1 byte. Okay? And we'll see better on that in 7. So it's got source address first, destination second here. Notice that's the opposite of the frame. The frame had destination first. Okay? And that was to allow cut-through forwarding to occur. Because then you didn't have to look at the source address. You could do just, all you need to get in far enough was just through that destination, and you could start your routing it back out. So then there's the source and the destination IP address, and then you got all the data down there. So that's the description of the header. They throw you some limitations on IP version 4. The big one is the number of addresses is run out. And I think in your online curriculum they give you a chart in there that shows you from the different international bodies of, or somewhere, where did I see that? I don't think it was in there. Somewhere where I saw the chart that tells you a few years ago when everybody was going to run out of addresses or had run out of addresses. That may be in 2601. Are you in 2601? Okay. You're not in 2601 either, are you?
I'm in 2601.
Okay. Was it in there that they had the chart in the last chapter or something? And that they showed Diana was going to run out in 2015 or something, and the Japanese had run out in 12 or something. And something that they had about 5 or 6 of the national groups and had dates on it in this little chart. I think it was in there. Dates weren't exactly right on the thing, but the concept was good on it, that we were running out of addresses. Okay? So, and that there were 4 billion of them. But the big part is, one, there's a lot of places in the world nobody pictured we're going to be on the internet, because everything's going on the internet now. Even the tribal people living off in the wilds of Africa or Asia or wherever have internet connections now. Their cars got a number of them. You all have a number of them. You've got the internet of the body type stuff like I just mentioned. You've got the pacemakers and all this other stuff. And if you had artificial limbs, that those things are getting highway internet connectivity to make them even more functional. And then about the routes to stuff, that they're saying that there was that. And that also, with us going to and using NAT, they're saying that is a limitation on it, but that was a way that we extended IP version 4. So then IP version 6 is out there, and they tell you there that in the early 90s they started looking on the replacement, and actually that was intended to be IP version 5, but then they threw it out, and there is, because they started realizing things was growing some, but they really didn't realize when they started on that of the explosion of the internet that was about ready to occur. They knew there was more usage of it coming on, but they didn't quite expect the explosion, and then they sure didn't see the explosion we're in now with the Internet of Things. Okay? So they tell you some things on that was that first they increased the address space. They went to 128-bit addresses instead of 32-bit. That doesn't just increase it by 4. That increases it exponentially. Does everybody follow on that? It's not just a multiplication of it, you exponentially increase. So making it 4 times as long doesn't make 4 times as many, it's exponential off that, and that's why you go to that unidillion. But if you add another digit in, you didn't just double the number of stuff. You've increased, well, by 10 at that point, okay? So then when you went 4 times as long, that just blew the number right on through the roof that you do it by. Security on IP version 4 of securing all that stuff was not very good there. IP version 6 has a lot better ways of encapsulating, etc., on the stuff and encrypting on it and such. So it makes it much better on that. They reduced the number of fields that's in there, actually. And that type of service thing that we saw back there, differentiated services, was actually a priority thing, and that is used a little bit, but not much. That does come into play of where you can do the denial of service attacks. And so they go through, they mention that one through you, and show you a little bit of a chart there, which that's a good one. And I really haven't seen most of those show that in terms of it, for you to see what all those other combinations of things are. So that they go through the trillions, the quadrillions, and you actually do see that number occasionally mentioned out there in the world today. And then you go on up to all those other things and end up with a unidillion. Okay? And like I say, that one there, I told you it was with 30 zeros after it. That would really be 36 zeros after it, since it's 10 raised to the power of 36. I was off by a couple of digits. So I was cheating you a few addresses. The encapsulating, they improved on that one, and so that it works a little bit better on that. Now, with IP version 4, we're going to talk about the addresses being in octets, because each of them is 1 byte long and it's 8 bits in there, so they're octets. And IP version 6, we're going to talk about hextets. Okay? And that's where they're doing it in hexadecimal. So just be aware of that one. And then they really don't do the checksums anymore or any of that. They really leave that to the outside. So they show you the packet header here on page 286. Notice it's a lot simpler one, like they said it was supposed to be. So you got the version again. You've got traffic class instead of the differentiated service one there. But that's the same thing. They changed the name of some of these things on here. And then they got the flow label, and that goes into the priority also on it. The payload length is how long is the data portion, which you didn't have in the header on the other one. That actually got into the actual data area. And then the next header, and that is what protocol are we really using, is really what that's supposed to be telling us. I don't know why they went with that one. Time to live, they came up with a better name on it. It's the hop limit. They went with a real correct one on it. Okay? Because you're also going to find out that there's other things out there as we're putting stuff out there, that they're going to have other type times on them. That it's going to be measured in other ways sometimes. But it's a hop limit. And they don't tell you what those are. Then the source IP address and the destination IP address. And those are 128-bit long ones. All right. Questions on that? Now, when the host gets it, when it gets to a machine, to a router, it's been handed just the packet, because it's been stripped off passing up to it. Came into the router as a frame, but that got stripped off on the bottom layers and hands it off to it as a packet. It's going to look at that address of where it's going to. Have we gotten there yet? Okay? Are we on the correct network? It looks at the network portion of the address. If not, it then passes it back down to go to the next device. So fairly simple on that one. And as it notes there, host can send packets to itself. That's one you need to be aware of. And that we'll see how you do that, but you'll use the ping. But you can send it to yourself, which in IP version 4 is 127 dot something. And we're going to see about that in the next chapter. Okay? But it's normally 127.0.0.1, but it actually just has to start with 127. It can be anything else on the rest of the address. So that's going to be a loopback or address that sends to itself. That's a limitation on IP version 4. They went and reserved 10 million addresses just for that loopback address. And nobody uses hardly any that they didn't know on it. So they went and made it something simple and did that. IP version 6, this is one address I do know. And it is actually 31 zeros followed by 1. Okay? Or it will get condensed down to, and we'll see this in the next chapter, ::1. And that is the loopback address in IP version 6. So they only reserved one address for it in IP version 6. I think that's 10 million addresses if I remember right, in IP version 4. Okay? So you can send a message to yourself. You actually do that. When you have network connectivity problems with somebody, you want to be able to see, can you hit your network card? Is your machine actually able to hit that port to send out? You're not wanting to send out, you just want to know, can I get to the card? That is what this will do. If you get a response back, you successfully hit your card. Because the card's failing, that port's failing. All right, there's no sense in looking further to see where we're failing on out on the internet. Our problem is local. Okay? You can also send on out there. The next one they mention is to a local host. You can ping to another device on your network. Now, remember what I told you about ping before. In some cases, ping's blocked in some organizations. Apparently now y'all can actually ping in here, and that they allow, that the school server, from what I understand, actually does allow pinging now. Okay? Well, a lot of places block it because it's a big problem. But it can be protected now, so places are opening back up. So you could ping to another machine. So you could ping Christy's machine to see, can I actually reach your machine in here? So is the network actually working in the school? Or do we have a problem of the network within the school? So the fact you couldn't get to Blackboard, we want to figure out, is it really something in here, or is it something out there in the big wide world? Okay? If that works, then you can ping out there onto the network. And you can ping to a domain name or to an IP address out there. CNN is used a lot of times. I use CNN a lot of times to do that. It's short. It's only 3 letters long. Okay? And they let pings through at CNN. Now, if you hit a number of them at it, I'm sure they block them. That when you just send a ping in there, and actually you send 5 pings at a time, 4 or 5 pings at a time, it's going to let that through. But if you go to sending a number, it's going to block them on it to keep you from knocking their network down. So then you could test out to some different spots to see, can I get out onto the internet? And if I can get out on the internet, can I get to different spots, or is it just Blackboard's down? Or, like this weekend, wouldn't let you log on. Blackboard was up, and rest assured, I got emails from several students that told me Blackboard was down. It was actually up because it gave you the log-on screen, it just wouldn't let you log on. Okay? Because something was crazy about the single server log-on for students. But it would let the faculty log on. And that confused everything. Because if y'all wrote one of us, our reply back was, it's working. We're on. And that we didn't realize it wasn't working for y'all. All right. So it will, if it's going to one, look to see does it belong where it is, the message. Does it belong on the network we're on? And if it doesn't belong on the network we're on, does it know how to get to where it's supposed to go? What way to get there? If it doesn't know anything about that address, when it looks in the routing table, that it looks at the addresses it knows about, and it doesn't know about any of them, it's then going to go to the default gateway. So you've got to have a default gateway there. If you don't have a default gateway, you can't go anywhere that you haven't been before because it doesn't know how to get there. Does that make sense to y'all? And it's a gateway. Think about it like a gate out of a backyard that's fenced in. That's the way to get out of the backyard, right? No, y'all aren't allowed to climb over the fence. We got razor wire on top. 3 rows of it. Okay? You've got to go through the gate. And we'll stay with a fence around there. So you will set up a default gateway, and that's going to be the address to your router that connects you on to getting onto the internet. Does that make sense? Usually it's the router that connects that the internet, your connection to the internet's coming through. But it could be the router that connects you to the next router, that connects you to the next router, that finally gets you to the router that actually connects out to the internet. Does that make sense to everybody? But usually in most of your drawings and questions and stuff, you're going to see it in terms of, unless you get into the real advanced stuff, you're going to see it normally talking about that router is the router that connects you to the real world. Or maybe another 1 or 2 routers, but nothing complicated. So the default gateway is an important one. It's going to route your traffic to your other networks. And it does have a local address, just like the other devices on here. So our router that we're connecting to for the student machines has got an address on the interface that connects in with all of these others on the same physical network. It's got a same network address as all of these devices in here. Does that make sense to everybody? It's just, and as far as the network's concerned, it doesn't see it any different. It looks just like a PC to it. They all look the same. And it's just, where do I send that traffic to? That's the device. If it doesn't know where to send it there. Now, when you're setting up the routers to set up the default gateway, on the PC, it actually says default gateway and you put it in. If any of you have gone in and looked at the network connections, it asks you for the IP address of the machine, the subnet mask, which we'll talk about in the next chapter, but that tells you what part of the address is the network, what part is the unique part for that host. And then the third thing is, it will ask you what's the default gateway. And that's where you tell it, where's that machine to send stuff that it doesn't belong on this network, so it doesn't know where to send it. Okay? Or anything that it doesn't see in its routing table, that it doesn't know where to send it. If it doesn't know where to send it, here's the address to use. Okay? As it sorts it on out. Now, on the routers, that was where I was going to. On the Cisco routers, to set up the address on there of the default gateway, assuming you're using command line interface. And some of the different routers actually do have a GUI on them, but that's not what they're teaching you in this stuff, because they really want you to be able to use the command line interface, the CLI. That when you go to set up the default gateway, you're going to set that up by using what they're going to call a quad 0 address. You're going to tell it that the IP address for that you're setting it up for, because you're setting up a routing table entry, so you tell it what's the interface address of that interface it's going to. But you're going to tell it it's a quad 0, so you can give it an address of all zeros, a subnet mask of all zeros, and then tell it what's the actual address of that port, and that builds it in the routing table to say send it to that address if it doesn't know anything else. and sets it up as default gateway. So when you see something about quad 0, it's the default gateway. So just think quad 0 as default gateway. And you'll notice they show you that one down there in the routing table on page 290. That the very first entry they've got there in that routing table is 0.0.0.0, subnet mask or net mask 0.0.0.0, and the gateway of what the address is it's to go to and what its interface is. The metric is a measurement of how hard is it to get to that location. That may be in terms of hops, it may be in terms of some other type of measurement. So if you'll go to ask me on that one. So then they mention about when it makes that forwarding decision. It's the same thing talking about from the PC, the router does the same type of thing. Is it something that's a directly connected router, or are we sending it to another router that we're directly connected to? And when we look at routing tables, we'll see that it tells us which ones are directly connected to us. Or is it a remote router? It's a router beyond the other routers that we're trying to get it to. And then that it will have a default route of here's the way to go if it doesn't know where to go. And so they talk about the IP version 4 routing table there. They mention about the directly connected routing table entries. They start with a letter C. And then if it's actually if it's an interface on this router, it's an L. A C is a router that's directly connected to this router. That's an address that's on another router that's directly connected. An L is one that's an interface on the actual router you're writing this on, or that you're looking at the report on. Pretty logical on those two letters. And then the remote ones will have some different letters and stuff showing on them. So they mention about that. And then they tell you about how did it figure it out and that information. And on that metric on there, the lower the value, the better it is. It's the shorter way. So you want it to use whichever route you want it to preferably use, you give that a lower number. It's sort of like if I tell you there's 5 different routes to get from here to Chattanooga, the one you want to take is the one that I tell you is the least miles or the least amount of time, right? And depending on which metric you're wanting to use, is it time or is it distance? Because it may be he's most concerned about how much gas is he going to burn there. So distance is his big thing. And you've only got X amount of time to get there to whatever you're going to, so time is your concern. And so you look at that metric. In both cases, you're looking for the least amount. Okay? So metrics can be measuring different things on it. The next hop address is where's it go to next to get to where it's going to go to ultimately. So I've told you on those. All right, then they talk about the routers and tell you a little bit about them. And we're talking about the commercial big routers like this one. Okay? So whatever they're talking on routers later in the chapter, it's these. And how you're setting them up. And y'all have already done a little bit of that anyway, but now they're explaining it to you. And that there's different ones of those. And so they note there that a branch will have a small one. That you've got a bigger one, these, when you're connecting out to your WANs. But you could be using small ones too, although Cisco doesn't make these anymore. They sold it off to somebody. Linksys isn't owned by them anymore. It was. But they're still making some other small ones, but not into the home market anymore. Cisco decided they didn't want to be in the home market. And then the service provider has the really big ones and the real expensive ones. Some of those cost, besides tens to hundreds of thousands of dollars, you could spend $1 million on some of those routers. And we don't have any of those sitting here. that none of y'all have come off all that money you've got and bought us one. Because whenever the last time there was a winner in the lottery, one of y'all won it, I know. But y'all haven't won it in the last few weeks, so we got it growing still. So then they talk about inside the router, and we're really talking Cisco routers primarily, but it really is the same type thing for other routers too, whatever brand. It just varies a little bit. There is RAM in there, and the router is actually a PC. Do y'all follow on that? It's just limited, and you can actually take a PC and make it into a router. All you got to do, as long as you got at least 2 network connections on a PC, is a router. Do y'all follow on that? So they mentioned about the RAM. It's very limited in it because basically, for most purposes, you're just using command line interface, although you do have some limited GUI on some of them now. Okay? And actually, Test Out tries to teach that one in their course. Okay? Using the Cisco GUI on it. And so they note that there's stuff in the RAM. Your iOS is the operating system that Cisco uses. So it's an internet operating system. And then the routing table is kept in there. The ARP cache is kept in there and such. There is ROM in there also, just like on your PC, which is used to actually boot the thing from. Because that's got your crucial initial startup information. Doesn't change. There's NVRAM. That is your permanent storage, and that's where you'll actually save your configuration files to. When y'all did the copy run start, it saved it to the NVRAM, the non-volatile RAM. Okay? Instead of having a disk drive in there, and actually now the rest of the world is moving over to the same direction, it's using flash memory in there, which is why it's non-volatile RAM. Okay? And it keeps it in there. And then they mention also they've got the flash memory on there too. So you do have non-volatile RAM in there, and then you've actually got flash memory, which if you notice on these new ones, there's actually a removable flash card on them. Even the older ones where you don't see that flash card on there, they've got built-in flash memory. But now they've gone to using a removable card for it. So you can build some other things on it that some of it gets kept stored into the NVRAM, and then some of it stored in the flash. And when you set the boot up process for the router, you can tell it where it's going to get the configuration file to boot up from. Okay? But the iOS is actually built in there on the ROM. But it's got to be set up for it. And then they talk about the stuff that's inside there. And if you notice on that picture there on 299, that looks like a PC. You got a power supply sitting there with a fan on it. And you've got the memory areas and the processor and everything else all sitting in there. It's just a limited level one. Very limited on how much it's got in there. So you're really going back to using an 80s computer that runs your network. Okay? And then they talk about your connections that you've got on there that come on the thing. So that they mentioned the flash memory. Got a nice little flash card. And then I say the older ones, actually it's not right there, but those little ones sitting over there by him, their flash is built inside. It's not a removable card. And one of these 2 slots here, we haven't put it into here. There should be a serial connection, which they're showing you there as the number 6. Yeah. So we've got console ports. Got a console port right there. Then we've got a gigabit Ethernet, which actually we do on this one. that we've got 2 of them right here. Actually, no, these are fast Ethernet. No, they're FE, so they would be gigabit. They are gigabit. Okay. No, they're fast Ethernet. Correction. They would be G's. I thought they should have been G. We've got a USB port sitting here, which actually I've never used on one of these. That gives us some additional storage space besides what the flash has got. And so I've never used. We've got an auxiliary port sitting right there. It's an RJ45 port also. And then the enhanced WAN interface ports, which are actually fancy serial ports. That you'll use for connecting router to router. And these newer ones have got changeable ports on them and actually don't have a port in them on most of them when they came in, but we got ports sitting in the box back there that we need to take these off and slide in the port. And then they talk about some of these ports on it. You could go through the console port to go in and configure them, which is what y'all would normally do in here. Or you could do secure shell or SSH, which is actually what, when you went through using the console cable, you use SSH to do that one. Or you could use Telnet on it, but as your other alternative. And it's going through a virtual one. However, Telnet versus SSH, if you're just doing it locally to it, which you should, then Telnet's fine. But if you're going to come across the internet going into it, you want to use SSH. Okay? Because SSH encrypts the traffic. Telnet is completely all open. But as long as we're just plugged straight into it, Telnet's fine. Nobody's going to steal it from us anyway right there. If they get on that cable from your PC to that router sitting right there to steal the traffic, you know they're there. Because they just pushed you out of the way to get up to the machine. Then they talk about on the booting up, that when it starts up, it's going to go to the flash memory, get the iOS image. So that's getting the actual operating system. And loads it into the RAM. Goes to the NVRAM to get the config file. Okay? And loads those in. And then, so it's going to then load the iOS and then use the config file to set up the iOS to what our local needs are. Similar to on Windows. Windows starts, Windows then grabs the registry file, which is the same thing as your config file basically, and figures out how do you want this machine set up that you're working on. Does that make sense to y'all? Because Windows is using that registry file to get the information from, which is a lot more complicated than that config file on the Cisco devices. But probably all of you have at least gone in and seen the registry file, whether you've changed anything in there or not. And you also know all the big warnings about it. Okay? Because you can mess up everything, because if it gets goofed up right, you can set Windows off. You can throw Windows onto that subway where it can't get off. And so it's going to die right there on you. Alright. So when it goes to do it, it's going to figure out where to go get that iOS from. It could come from several places, but there is that ROM part that tells it to go here first, and then that tells it where to go look next. Same thing on your PC. When it goes to start up, it doesn't go straight to the hard drive. It's got to go know where to go to the hard drive, so there is actually a ROM file sitting on your PC that says, go look at the disk drive. And remember, that's in the CMOS, and that you can change that. Because on your regular PC, you can change the boot order, right? And tell it to go look at a CD or DVD, or to go look at this disk or that disk or something else to go get where to boot from. That's the same thing they're talking here, of where's it going to go get the iOS from. Generally from the flash, although it could come from a FTP server. That's a security item. Because if you do it from the flash, somebody could get into your machine and change your iOS to a seized control of it. Okay? If you do it from a TFTP server, you're pulling that off of another machine that's connected to that machine, and that goes and grabs it from there. Well, not only do they have to get into your machine, they got to get into that machine to actually make the changes. But as soon as it reboots, it's going to go back to grab off that machine. So you've made it a little bit more secure. So you will see them sometimes using a TFTP server where it's grabbing from another machine where it grabs the image from. And it'll also be a way to, for if you've got the iOS is messed up on the machine, use the TFTP, it grabs it from the other, and you can get it straightened back out again and get it back running again. And then where are the config files? They could, again, they're most likely in the NVRAM, but they could be located on the TFTP server, or you could actually have them on the console port, where a device that's connected on the console port supply, it grabs it from there and pulls it in. And so you can override on that to get it in there. Because after all, if it got goofed up in there, you can't get back into it. You got to have a way you can get a default one set back in there. So there's your choice on it. They didn't tell you about the show version command, which will tell you what version of iOS you're running. Generally, you're going to see those as 12 to 15. 15 is the current one, if I remember right. And then they go through and mention about some where you're going through to set stuff up on it. Y'all have actually already done this stuff, if you remember back in chapter 1, when they had you actually go in and do a couple of things to it real quick. Now they tell you about what you've done already. That's really good, right? Would have been nice to have understood what in the world you were doing before, instead of just doing. So they tell you about how to set up your ports, how to set up your password, your secret password, the banner of the day. So they take you through and show you on those. And you should have an assignment in this chapter that has you go through all the stuff again too. So you should be doing it. Yeah, because I know you got 6.413, which is setting up those settings. So I remember that number. And so then you're going to configure the interfaces. Now on their stuff there, they've got setting them up. They're spelling out the whole words. You can abbreviate interface as INT if y'all's typing is like my typing. You don't want to type that whole long word there. 8 characters long if you can type it 3 characters. Okay? No shutdown. Remember, on interfaces, you do have to start them because by default they are shut down. And that's a good thing to do from a security viewpoint. Shut down anything you're not using. Services, interfaces, programs, protocols. Have them all shut down. Ports. Have them all shut down except the ones you're using. And that's what you really want to do on firewalls, so that a firewall really can protect you. Because if ports aren't shut down, the firewall just lets everything through. It's when you got ports shut down, it says, no, you can't come through that way. We've locked that door. But no shutdown is the command you're going to use to actually start that interface then. And that's where I told y'all before, don't go back and tell your English teachers what I'm teaching you in here. Okay? Because you remember the English teacher told you don't use a double negative. And what's no shutdown? You're getting into a double negative there, right? But it's sort of like Windows, you're already used to that, because if you want to shut down Windows, what do? You do it backwards way on that too, right? You go to start, shut it down. Here, to start it up, you go to shut down. Essentially. So it's essentially the dead opposite of what you're doing in Windows. To start it, tell it don't shut it down. Starts it. Okay? to shut down Windows, you got to start. I'm going, huh? And then they tell you about how you can verify them, that you can do a show IP interface brief. And again, those can be abbreviated things in there. You're looking for it to be up and up. What that's telling you is that the physical device is working and that the software is working for it. Because it will tell you if it's up and down, which usually is it's administratively down. The device is working, but you have it turned off. You didn't start it. Okay? So if you see up and down, administratively down, you know you need to go back to that interface and do a no shutdown. And it'll probably go to work for you. Because administratively down says somebody has actually shut it down, or else that it was down by default, not that it shut down because there was a problem. Does that make sense to y'all? So then you do on that, they mentioned about the ping. You can ping something to see that you really can use that interface also. And actually in Cisco iOS, when you do the ping command, besides pinging to a location, you can tell it where you're pinging from. So we can actually sit on one router and tell it to ping it from another router. Because we can tell it ping to CNN from this IP address that's sitting on another router. And so you can ping from different addresses also. And it will send the message to there and then send out the ping from there. As opposed to on Windows, all you can do is just tell it where you're pinging to. You can also tell it on the ping in Cisco, which you'll see later. You can tell it how many pings to send out also. Instead of, I think Windows sends, it either sends 4 or 5 by default, and Cisco sends the other by default. Okay? 4 or 5 initial pings. I really think Windows is 4, I'm pretty sure. And Cisco is 5. Now Cisco is not going to come back and give you that whole line of information about it made the attachment. It's just going to give you an exclamation point there to show that it did connect. So if you get 5 exclamation points, every one of them went through and came back. If it doesn't go through, it'll give you an underscore, so you got basically a blank for the spot. And you want to get exclamation points. In Windows, you want to get the lines all coming back and saying acknowledgements. And it gives you a whole long line as opposed to a short little message that says it couldn't do it for whatever reason. Then they show you how to set up the default gateway. They talk about that, of choosing it. Well, I tell you about choosing it, but I really don't see them telling you how to set it up right there. Tell you to configure it. Oh, configure it for a host, not for the, well, there. Okay, so they're going, you can use default gateway also in the command now, instead of having to do the 0 dot. Default dash gateway is the same as doing the 4 zeros to 4 zeros. Okay, so you can do that on the modern versions. I forget about that one. But if you talk to real Cisco people, they're going to talk quad 0 always, the ones that are using it all the time. So now y'all know the language you need to use as you're going into an interview with the person that does really know Cisco versus the one that sort of knows something that you might want to throw the default gateway term at them too. But if you throw quad 0 at the one that really knows it, they're going to sit there and understand your English perfectly fine. And besides that, they're going to sit there and go, okay, they know how to talk it. All right, that there is chapter 6. Questions? We've wandered all around, but we've really covered the whole chapter. I don't think I skipped anything in there. And I am approved to go to North Carolina in a week, so I am going to be gone because I got presidential approval back yesterday on that. So I will be gone week after next. The other one is next Thursday, no class then. So that means 3 in a row you don't have class, but you still got to study the material and you got to take the test still. Remember, you do get 2 tries at the test. Okay? And if it doesn't show the higher test score to you, send me a note on it. But I think it's working correctly now. I think Cisco finally got that fixed right. Or if you take it the second time, it'll give you whichever's the higher score. It was, for a long time there, it wouldn't change the score on you. And then for a little bit there, it gave you the second score. It didn't make any difference whether it was higher or lower. And y'all really want the higher score. Now in Blackboard, I can actually go in there and choose to use the lower score if I want, when I let y'all do stuff multiple times. Why in the world I would do that, I don't know. Unless we're setting up a routing table through testing. Because remember, lower number was good number. But normally, for your score in class, you want a high number, right? Y'all would like a number closer to 100. You really don't want numbers closer to 0. But if it doesn't show it correctly, write me and tell me. And then it does let me see stuff. Sometimes I have to dig a little bit to find it in there, and then I can fix it. And occasionally, and then sometimes I do have that where people, like on the online classes where they got choice of discussion or the collaborate session, sometimes I do fail to enter that, or it has also, that one still goofs up on it, that it has both numbers in it. It actually goes with the last number entered. So if they go into a discussion after I've put a collaborate score in there, it goes with the score they got on the discussion, not their collaborate score. And so if they only did one part of the discussion, they got a 33, but they did the collaborate, which gave them 100, and the grade that shows out there is a 33. And so I get a note every so often from one of them about that. And all I have to do is go in and overwrite it. And I can see the 2 numbers right off the bat, and I know what it is. And usually I know right off that that person was in collaborate. And so I can fix it real quick. Hopefully I'll get some more grading done in the next couple of days. I really thought I was probably going to work on some of that last night, but it really didn't. Didn't get home till after 9 o'clock.